Dr. Sivamani Selvaraju from University of Technology and Applied Sciences, Oman. Hello, sir.
Yes, ma'am. Good
Yeah,
afternoon.
good afternoon. Pleasure to have you here. Now, floor is yours. You please go ahead with your talk.
So I hope my presentation is visible.
Yes, it is.
Okay. So good afternoon to all, and I would like to thank SciTech Series for organizing such a wonderful technical event, World Congress on Organic Chemistry, yesterday and today. And I would like to acknowledge the management of University of Technology and Applied Sciences, Salala, for giving me an opportunity to present in this wonderful conference. So on today's my presentation is to throw a light on the review of microplastics in drinking water and agricultural soil, assessing its contamination sources, risks, and mitigation strategies. So I would like to thank my co-author Nishat Fatma. She is from Chemistry Division of College of Engineering and Technology, Engineering Department, University of Technology and Applied Sciences, Salara, Oman. And I am Dr. Sivamani Selvaraju, Chemical Engineering Division from College of Engineering and Technology, Engineering Department, University of Technology and Applied Sciences, Salalah, Oman. So I am going to give an overview on introduction, its sources, risks, direction, mitigation strategies, and finally the summary. So first of all, we will know what are called microplastics. So the microplastics are the polymeric particles or the polymeric substances that has the size of less than 5 millimeter. And normally the microplastics are produced from the macroplastics, that are the larger plastic particles that are manufactured from the industrial use or from the environmental discharge. And almost nowadays we can say the microplastics are everywhere, but they are predominantly present in water, soil, and air. And in the recent studies, before a month or 2 months ago, they found that the microplastics are found in brain and they are present in blood and so on. And actually, the microplastics, because of its small size, they are very resistant pollutant with potential risk to ecosystem and human health. So now we will see about sources of contamination. So the microplastics are present in drinking water in the form of tap water. So the tap water gets the microplastic because of the degradation of plastic pipes and industrial discharge without proper treatment of effluent, and with partial treatment of effluent from the industries. And the microplastics are present in bottled water because of the sources of packaging and the degradation of bottles during transportation. And the microplastics are present in groundwater because of infiltration from runoff, because of disposal of waste and landfills. So the microplastics are also present in soil because of mulching. Mulching means actually we are used to cover the plants with some form of plastic materials for enhance its growth. So because of that plastic mulching, the degradation impacts the soil health. And the irrigation, because of the contaminated water that is sent to plants through the plastic pipes, because of that the soil gets microplastic pollution or contamination. And the treated sewage sludge introduces microplastics into soils. And when you see the interaction between water and soil, actually the mainly due to runoff and infiltration, the microplastic cycle between soil and water complicate the management efforts. So there are so many risks and impacts because of microplastic pollution. Actually, first of all, we will see the. Relax, Nana. Excuse me. Yes. Yeah. No. Am I audible?
Yes,
Yes,
yes.
yes, you are.
So, when I am talking about risks and impacts, actually the environmental impact on ecosystems. Actually, the effect on aquatic life is due to ingestion because of the physical harm and toxicity, and it affects the soil health because it alters the soil structure directly, and it reduces fertility, and it disturbs the nutrient cycles. And the human health is getting risked because of consuming the water contaminated with microplastics because of the toxic chemicals linked to the health issues. And when we consume food, the microplastics are the sources from seafood and the food crops which raise health concerns to us. And it affect agricultural productivity and food security because of the microplastic reduces the crop yield and threaten the sustainability cycle. And also it affects the food security because and which leads to the damaging economic stability of country in agriculture. And these microplastics can be detected using various techniques. So some of the techniques are microscopy, which is a very broader area, so which we know already. And the microscopy itself, the general microscopy, like optical microscopy and fluorescence microscopy, are used to identify microplastics. And some spectroscopic techniques are very widely used. The FTIR, through FTIR, the presence of microplastics can be identified through the functional groups. And Raman spectroscopy is also used. And from the chemical methods, the pyrolysis, gas chromatography, mass spectra, and differential scanning calorimeter are used to identify microplastics. And apart from these instrumental methods, a traditional gravimetric method is also used to find the presence of microplastics through filtration and separation of density based on the different particle sizes. And to up to date, so the automated imaging systems are also used based on artificial intelligence. And there are some challenges in detection and monitoring of microplastics. Actually, the first one is the expertise, technical expertise. The major problem is technical expertise because the technical expertise on identifying microplastic by instrumental methods is lacking, and the lack of standard methods or standardized procedures are lacking, and the sample preparation itself, the technicians feel difficulty. And if we are assuming that the sample contains only microplastics, but sometimes it may contain some other organic matter also, which interferes in the detection of microplastics. And as we know already, these microplastics are tiny particles, and it needs very advanced technology to identify them. So obviously, the cost is very high and accessibility is limited. And the various mitigation strategies. So the water treatment methods. The one of the general water treatment method or commonly used water treatment method that is used in our household is filtration, and it is very effective for removing microplastics. But still, the very tiny particles of microplastics are not effectively removed through filtration. And the coagulation and flocculation. So as we all know, the coagulants and flocculants are added to the wastewater, where these coagulants and flocculants attach to the pollutants and they form a flock, and because of the higher density they settle down at the bottom. So the aggregates, the coagulants and flocculants aggregates the microplastic for easier removal. And the advanced oxidation process is a chemical process that break down plastics into less harmful compounds. It breaks down microplastics, toxic microplastics to less harmful components. And the absorption surface phenomena and that captures microplastics and organic components through high surface area absorbance. And the last method is the biological treatment method. So still many research is carrying out on biological treatments, and even we have worked on biodegradation of microplastics using various fungus. And coming to the sustainable agriculture practices, so we have to reduce plastic at the point of source, and the crop rotation and diversification improve the soil health. And again, the thing is that the reduced plastic should be reduced at the point of source. So the organic farming is the best method of avoiding plastic in agriculture. So that decreases the reliance on synthetic plastics. And the composting, actually, composting takes long time to degrade the plastic, but still we have to develop a recent technology on composting to reduce plastic degradation. And we have to create awareness and education on microplastics at the school and university levels. And from the government point of view, there are various policy measures that has to be taken, like banning of microplastics or banning of macroplastics, and levying very heavy taxes on using plastics. And there should be standards for microplastics, like regulatory frameworks to limit plastic content in products. And the financial incentives should be encouraged those who are not using plastics, so that the more public they can avoid using the plastic, which leads to the sustainable practices. And more funding should be awarded to the universities and schools to enhance the research on microplastic reduction. And as in the previous slide, I told about creating awareness to the students. And here, when we talk about the government, so we have to create awareness for the public also, so that the impact of microplastics is known to the public and its usage will be reduced. So, summarizing the entire presentation, so the pervasive presence of microplastics in drinking water and soil pose significant environmental and public health challenges, and the finding the microplastics at the source itself solve the problem by half, and it is very, very important for water as well as soil sources. And the potential risks that is associated with the microplastics should be known to all the people, and it should be underscored the urgency for comprehensive monitoring and mitigation efforts. And the effective strategies for addressing microplastic contamination must involve a multifaceted approach, integrating advanced reduction technologies, sustainable agriculture practices, and robust regulatory frameworks. So, the public awareness and education are also crucial in fostering responsible plastic use and promoting alternatives. So, by prioritizing research, policy initiatives, and community engagement, definitely we can reduce the microplastics in drinking water and soil and make the environment neat and clean. So, thank you so much for listening to my presentation. Now, I am looking for the queries. Thank you.
Yeah, I'm on. So thank you, Dr. Selvaraju. It was wonderful presentation on your applied research. It's very much need of the hour from the industrial point of view. I hope everyone has enjoyed it and looking forward for interaction with you by all the audience.